In this video, we're computing the integral of secant to the fourth x dx, and this is a classic trigonometric integral. The key to starting this thing out is to remember that we have an identity for secant squared. We can relate that to the tangent function. So maybe we'll start by just splitting this into secant squared times secant squared. And then we go, okay, one of these could be related to the tangent function by a Pythagorean identity. Maybe you have to remind yourself of the details, but you should at least remember there's a relationship between secant squared and the tangent function. So suppose we just highlight this one and we go, we'll express that in terms of the tangent function. Well, what's left right next to it is the derivative of the tangent function. And this is really promising because if I can get an expression in terms of tangent functions sitting next to the derivative of the tangent function, that takes care of the chain rule backwards. So of course we have to put in the details and see how it works out. So I start with secant squared x, the derivative of the tangent function, and then I have to rewrite the other secant squared in terms of the tangent function. So maybe you're a little bit rusty with your trigonometric identities and you have to go back and rederive this real quick. It doesn't really take that long. This is one that's not hard to remember. Sine squared plus cosine squared is 1. And this pops directly out of the definition of sine and cosine on the unit circle. Those are just legs of a right triangle whose hypotenuse is 1. And all we're looking at is the Pythagorean theorem. And then I go, okay, I'm going to relate this to the secant function, which is 1 over the cosine function. So what I'm going to do is divide both sides by cosine squared. And this first term, we can think of that as sine divided by cosine all squared. That's tangent squared. So I have tangent squared x. The second term is just 1. And then on the right-hand side of the equation is 1 over the cosine all squared, which is secant squared x. So there's the details. Secant squared can be written as tangent squared x plus 1. Okay, so then just to make it really clear how the chain rule is going to operate backwards here, I can distribute that secant squared. And I have secant squared x times tangent squared x. That's a power of the tangent function sitting right next to the derivative of the tangent function. And then in my second term, I have secant squared x, which is just the derivative of the tangent function. So anytime I have a power of a function sitting right next to the derivative of that function, I can see the chain rule backwards. All I have to do is apply the power rule to this tangent function, and I end up with a 1/3 tangent cubed x. And that's just using the chain rule backwards. So if I verify my answer real quick by taking the derivative of this expression, 1/3 tangent cubed x, I would just differentiate with respect to the tangent function, and that gives me 3 tangent squared x, canceling the 1/3 out in front. And then you have to tack on the derivative of the tangent function because of the chain rule, and that's secant squared x, and we get back where we started. Now, if you don't like using the chain rule backwards informally, that's fine, but I think formal u substitutions can start to get really distracting as our problems get more complex, and that's why I advertise this informal chain rule backwards approach. But if you wanted to use a formal u substitution, you would let u be equal to tangent x and go from there. Now in our second term, we have secant squared x, and the antiderivative of that is just the tangent function. And it's an indefinite integral, so we're going to throw a plus c in there, and that's it. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.